Hey everyone, hopefully OdysseyWare is working all right for you, and I hope that everything's going okay so far for day two. Um, Today we're going to add on just a little bit with our subatomic particles and things that we know about atoms, looking mostly at neutrons. And so we still have to remember things from yesterday, like atomic number is the number of protons, and that the number of protons is the same as the number of neutrons, or number of electrons, because we're dealing with neutral atoms. But today we're going to focus on neutrons. Now, neutrons aren't something that you can find from your periodic table. It's something that we need to know the mass number for. And mass number also is not on the periodic table. So the mass number would either need to be given to you, or maybe it's something you are using to identify what type of atom of whatever element you're looking at. And so your mass number is not your number of protons plus your number of neutrons. And so your mass number is kind of like the mass of the nucleus of the atom. And so it's, again, your number of protons plus your number of neutrons. Again, this is not on the periodic table. When you're doing some of these, you might be like, oh, that number is really close to what's on the periodic table, but that is atomic mass, not mass number. And so don't look at that little decimal number on your periodic table. So when we're dealing with neutrons, again, the number of protons shouldn't change from element to element, but the number of neutrons within the nucleus with those protons can. And so isotopes have the same number of protons, but different number of neutrons. Again, if you change the number of protons, that changes what elements you're dealing with. If the number of neutrons changes, that does not change what element you're dealing with. It's purely a different isotope of that. And so when you're looking at an element, every atom of a certain element should have the same atomic number, but varying mass numbers depending on the number of neutrons. And so if we were to look at neon, now neon in nature can exist as three isotopes. And so there's three different types of neon atoms we could see. The first one is a neon atom that has 10 protons and 10 neutrons inside of it. The other one has, again, 10 protons, but 11 neutrons. And then another 10 protons and 12 neutrons. Again, notice the number of protons stays the same every time. That's because it is neon, and neon always has 10 protons. If it doesn't have 10, if it has 11, then it's not neon anymore, it's sodium. And if it had 9 protons, that's not neon, that's fluorine. And so since it's neon every time, number of protons stays the same. Also, number of electrons are going to stay the same because all these atoms of neon are neutral atoms. And so the number of protons has to balance the number of electrons. And so we have 10 protons, 10 electrons. The one thing that does change, even though it's neon every single time, is the number of neutrons. Number of neutrons, again, won't really affect much about your atom, other than that it can make your atom unstable. And so sometimes isotopes of elements are like radioactive. And so there can be some stability issues with the atom with different numbers of neutrons. Otherwise, you're dealing with the same element, mostly the same properties. And so looking at these, we see that we have neon 20, neon 21, and neon 22. And so this is actually how we name our isotopes. When you name them, you should always name the element, then put a dash, and then put the mass number. And so since this one had 10 protons and 10 neutrons, the mass number would be 20 because 10 plus 10 is 20. And so we would name that neon dash 20. So, and then the next one, the mass number is 21 because it's 10 plus 11. And so we name that neon 21. And then 10 plus 12 is 22. So neon 22. And so I also wrote that down here just so that after this video, it's in your notes and ready for you to look at. We can also represent this with shorthand notation. And so This right here represents what shorthand notation would look like. And so the X would be whatever symbol represents that element. So you have to look at the periodic table, find the symbol, and put that in. The A represents the mass number, and so this would be where you put your number of protons plus neutrons. And then your atomic number goes in the bottom, and so that's straight off the periodic table, or the number of protons. And so here's an example looking at an element. So this is hydrogen, so they used an H. The atomic number of hydrogen is a 1, and this one's mass number is 3, which means it has 1 proton, and so it must have 2 neutrons to make that a 3. Right, and so if we were to write shorthand notation for this neon 20, well, neon symbol off the periodic table is Ne, neon. This one had a mass number of 20 because there was 10 protons and 10 neutrons. And the atomic number of neon is 10. And so this would be shorthand notation for neon 20. If we were doing neon 21, everything stays the same because all we're changing is the mass number, the number of neutrons, and so that becomes 21. So that's neon 21. And then neon 22 would be neon 22, all right? So just looking at how these things change, so I'll look at hydrogen. Hydrogen has 1 proton, and so if it has 1 proton and no neutrons, then within the nucleus, we only have 1 proton. And so that would be hydrogen 1. It has a mass number of 1. So up here, it's going to show you protons and neutrons. So I'm going to add 1 neutron. And so now I have 1 proton, 1 neutron. 1 plus 1 is 2. And so we have hydrogen 2. That's exciting. All right, and notice this is a stable atom. So this is something we could definitely find in nature, just like hydrogen 1. If I added another neutron, this is unstable, so less likely to be found in nature, but I have 1 proton, 2 neutrons, so the mass number is 3, so this would be hydrogen 3, which is what we saw right here. This would be the shorthand notation for that, hydrogen 3, 1 proton. All right, I could look at this with other elements, so if I was looking at carbon, carbon has 6 protons and 6 neutrons. 6 plus 6 is 12, and so the mass number of this would be 12, and so this is carbon 12. If I added another neutron, it would be carbon 13, because now I have 6 plus 7. If I added another one, carbon 14. I could also take some out, and so if I had 6 protons but 5 neutrons, this would be carbon 11. And so again, one thing we want to make sure we notice is that the number of protons stayed the same all the time because it was the same element. It was carbon every single time. And again, we'll talk about some of these different isotopes tomorrow and how that relays into the number that you see on the periodic table. Also, we'll talk a little bit more about the stability of our atoms. So really quick, I'm going to switch over to my iPad and we're gonna just solve for some unknowns with given information. And so if you knew different things about your atom, could you solve or find how many subatomic particles you had based on what was given? And if it comes up here, there it goes. All right, so just ignore all this. Again, we went through things in such a different order this year that this is just a paper that I used in previous years. And so let's say I had an element of carbon or an atom of carbon. I know the mass number is 12, the number of electrons is 6, and the full name notation is carbon 12 for this. And so I just want to find the atomic number, number of protons, number of neutrons, and I want to write the shorthand notation. Right. Well, if I have carbon, I could look carbon up on the periodic table and find its atomic number. Its atomic number is 6. And that tells me that I have 6 protons because the atomic number is the number of protons. Another way you could have done this is you could have saw that you had 6 electrons. And if you have 6 electrons, that has to balance out how many protons you have to be a neutral atom. And so you would have 6 protons, which tells you your atomic number is 6. So you could have done that several ways. Right? The mass number of this is 12. Mass number is protons plus neutrons. And so if I have 6 protons, I would have to add 6 neutrons to give that a mass number of 12, because 6 plus 6 is 12. And so writing this, I would write it as C for carbon, the mass number up top, and the atomic number on the bottom. And so this would represent carbon 12. Right? In this next one, all I know is the atomic number and number of neutrons, and I want to find everything else. Well, if I know the atomic number, that makes it really easy to figure out what element I'm dealing with. The atomic number is 8, and so this must be oxygen. So I'm dealing with oxygen. Okay, atomic number again represents the number of protons, and so I have 8 protons. I'm going to jump ahead a little bit because I know the number of protons has to equal the number of electrons, and so that would be 8. The mass number is protons and neutrons combined, and so if I have 8 of each, the mass number is 16. And so this is O for oxygen. Mass number up top, that's 16. Atomic number on the bottom, which is 8. And this guy would be oxygen 16. All right, and the next one I'm dealing with hydrogen. Hydrogen has the atomic number 1 from the periodic table. It's the first element. The atomic number tells me number of protons, so 1. The mass number in this case is 1, and so if it's protons plus neutrons, and I know I have 1 proton, then I can't have any neutrons because 1 plus 0 is 1. How many electrons? Well, that has to balance number of protons, so also 1. And so hydrogen is an H. I'm putting the mass number up top, 1, and the atomic number on the bottom, 1. And so this would be shorthand notation for hydrogen 1. And this would be hydrogen 1. All right, I'll do one more, and then I think we should be good. So number of protons in this one is 6, which tells me my atomic number is 6. If I look up atomic number 6, which we've actually already done, but it is carbon, and so I'm dealing with carbon. The number of neutrons, well, I have to know mass number to know that, and I do. And so if the mass number is 14 and I have 6 protons, that means I have 8 neutrons, because 14 minus 6 is 8. And so this would be, again, a C for carbon, this time a 14 up top and a 6 on the bottom. Again, one thing you should notice is that in both of our carbons, I have a 6 on the bottom because that's number of protons, which has to stay the same for dealing with carbon. And so instead of this one being carbon 12, this one is carbon 14. All right, so I hope that all makes sense. If for some reason you need some help, remember, just email me or get a hold of me or jump on the Zoom sessions later. So I hope you all have a great day, and we'll see you again tomorrow. And I just got to get off of here. All right, see you later. Bye.